All right, so today I thought I'd go over some of the projects that we've done recently, more out to the Kitchener area, to kind of show you what this actually looks like in the built environment. Two of the projects are retrofit projects, to show you the type of things that we can actually do in an urban environment. So I'm going to go through the projects, and then I'm also going to go over some lessons learned, because this is a fairly new thing that we're doing in the region, and we're learning for every project. So the first one I want to talk about is Waterloo Street in London. This was a full street retrofit that was triggered because they wanted to do infrastructure upgrades. The 3 blocks that they were working on here, they decided to just do the 1 block as part of the retrofit program because the other 2 blocks had very large mature trees and no one wanted to see those trees get cut down. Now, when you're doing a retrofit, you have to consider what's already there. So in this area, we had very large boulevards. We had property lines that ended essentially at the front of the houses. And we had an entirely new infrastructure going in. So all of the stormwater pipes, all of the sanitary pipes, and all of the water pipes were being replaced. This was really an ideal situation for a retrofit because we didn't have to worry as much with utility conflicts. They were replacing them. They were actually taking the utilities right up to the houses. So we knew that all of that could go in before we put our rain gardens in. Now, there were a lot of trees on the area that we decided to do the retrofits. We did do tree removals. We also worked with the community to make sure that the trees that they really wanted to keep, we worked around them. We also ended up increasing what we call the IP ratio. So for every single piece of green infrastructure, we have a loading ratio. How much impervious we're sending to the pervious area. Typically in Ontario, we like a 15-to-1 ratio for bioretention. We bumped it up to 20-to-1 on some of these, just because the number of electrical boxes and the number of trees really reduced where we could build the rain gardens. Oops. We designed these for the 25-millimeter water quality event, and that was something the City of London wanted to see, because currently the street drains undetained, untreated to the Thames River. So this was really looking at improving an area that had no storm quality controls, no storm quantity controls, and providing some benefit. That 25 millimeters works out to be about the 90th percentile for London. It's probably a little closer to 30 millimeters in London. But that 90th percentile rain is really typical for a design process for LID. You'll see it used out in Vancouver, you see it used down in Florida, Philadelphia, across the world. And that generally equates to about an inch, 25 millimeters, unless you're out on the Pacific coast where it's much higher. So we had to sell this to the residents. Residents don't really care about stormwater. It's surprising. They really don't know a lot about it. They don't really want it on their properties. They don't know what you mean when you're talking about it. So we called it neighborhood beautification. We're going in, we're putting gardens in. It's gonna look great. But as part of that, in all the areas that we couldn't put a rain garden in, we decided to put a faux garden in. So everybody got plantings, regardless of whether it was for stormwater or not. And that's one way to get everyone on board, because everyone was getting the exact same thing. We wanted the plantings to be attractive. We actually didn't go the typical native grasses route. We went more with shrubs, irises, and a bit higher value planting, because we wanted it to be successful and taken up by the neighborhood. We also partnered with the neighborhood association. So one of the big things with green infrastructure is who is going to do the maintenance. Cities don't have a lot of money for maintenance. They don't really want to put in stuff like this that's going to cause a lot of maintenance. So here we have a neighborhood association who's doing all the weeding, all the watering, removing the trash. The only thing the city is responsible for is cleaning out the pretreatment sump and cleaning out the under drains. It's the only thing the city has to do. So we had some unintentional results here. This was a pilot project. It was a retrofit. So we have a full-size storm sewer in this street, size for the full 5-year flow with no volume reduction. That means when we get climate change, or if we get a more intense storm, we'll have additional capacity in the system. So that pipe now has the capacity to hold much more than just the typical 5-year. And we've also provided some surface storage to help with flooding events. This might not happen on every retrofit because there is a chance to downsize your infrastructure to save some money. But at the same time, by keeping your infrastructure the same size, if you're not doing a replacement and just a retrofit, it does give you some climate change benefits. So typically we do decrease our stormwater infrastructure downstream. It does save money. Developers like it when we save them money. But it might be more costly on the front end to keep the infrastructure the same size, but it could save us money in the long run. So the second project I'm going to talk about is Gemini Motors. And this was a private development. They wanted to expand their parking, and they had a totally different reason for having to do this. City of Kitchener required them to do this because the storm sewer in the front of their lot had no capacity. It's at 100% capacity. So the city decided that they had to store and infiltrate all the rainfall for that parking lot for up to the 5-year storm. That's roughly 50-ish millimeters, so double what our last project was. City was also worried about erosion in the creek that the storm sewer went to that was about 500 meters away. Another problem with this is it was located on a railroad embankment. Very steep area, not really ideal for infiltration. Saving grace, we did have really good soils. We had sand soils that really soaked up. We had about 200 millimeters per hour infiltration. One of the design modifications we did, as you can see on the left, your left, we put in some concrete trench damming within the subsurface rock trench in order to hold the water back. So even though we couldn't give it a flat surface because that's a lot of rock, even though we couldn't not have it on the embankment, we did try to hold that water back to prevent it from coming out of the retaining walls. This was one of the first private retrofit situations in Kitchener. As you can imagine, the city was really nervous about it. We had to provide a maintenance regimen. We had to go out and do much more testing than I have ever done on a site to prove that it would work. And the design costs were quite a bit more than a traditional parking lot. That's what happens when you have several rounds of city comments and a new technology. But Gemini Motors was really keen to be able to market themselves as green and to be able to say that they were one of the first sites to do this in Kitchener. So they decided to move forward with it. And we worked with them on the design and the construction. And it looks really good now. So the third project, and we're actually building this right now in the minus 20-degree weather, is RBJ Schlegel Park in Kitchener. This is a greenfield project. But what's unique about this project is this site has no natural stormwater outlet. It's a 16-hectare site that drains to itself. So we are actually doing regional detention on this site. So that Hurricane Hazel storm that was mentioned earlier this morning, it's 285 millimeters over 2 days, and we're infiltrating all of it. It also supports the City of Kitchener's new infiltration target. City of Kitchener has decided that for every site that gets developed, 12.5 millimeters from every surface, whether it's paved or whether it's vegetated, has to be infiltrated. So we're going well beyond that, but we are meeting the city's new infiltration targets. It's currently a field, an agricultural field, and the groundwater is more than 20 meters below the ground. That's fantastic. One of the biggest barriers to LID in this province is high groundwater. You need a 1 meter separation from the groundwater table to the bottom of your infiltration. Soils are also silty sand and sandy silts. They're not fantastic, but they have 43 millimeters per hour, which is good enough to do what we need to do. So we did a integrated approach here. We have a lot of different things all connected together. We have rain gardens for the parking lot that are going to treat and infiltrate. We have an infiltration gallery under every single playing field, the artificial ones and the natural ones. We have pervious paving for pedestrian areas, infiltration trenches for rooftops. We also have a large dry detention basin with a infiltration gallery under it. And that's really the powerhouse of this site. That's where the most of the things are happening. So this is the example or the architectural mock-up. And you can see kind of that top area around the playing fields. Fortunately, I don't think the laser pointer works. It's big. That entire area is infiltration with detention over top, or retention in this case, because there's no outlet. And it steps up. So first it floods the smaller area, and then it steps up to the larger area, and then eventually it actually takes some of that circle as well, the cricket pitch. So the dry pond is 25,000 cubic meters. It's huge. And it's actually designed so that there's no water in it for anything under a 5-year. So that infiltration trench below it holds all the water up to the 5-year so that people can still use that area. It's a free play field area for people to use within the park. We figured if it's more than a 5-year storm, people aren't going to be out there. So it's kind of a balance between using it for stormwater and using it for recreation. Now, there's some interesting things about this. We did put parking lot rain gardens in. Our rain gardens did not have that soil space for trees. They just didn't have the right soil space. So instead of taking out the trees, because everyone wants to park under a tree, we decided to take out parking spots. So everywhere that we had a tree, we removed the parking spot beside it and turned that into our rain garden. So every single area where there's a tree, there's also a rain garden, and we have actually double the soil space that we would have just by putting rain gardens in. We're having some challenges with this park. We are constructing right now. We went out to do our infiltration testing in minus 20-degree weather. It worked, but it was really cold. And I'm actually surprised it didn't freeze on us as we were excavating. We also have to use the dry pond as the sediment pond. There's no avoiding it. The way the site's set up, everything drains to that area. We'd have to really change all the existing grading that's already there to make it not drain there. So that's led to some concerns with protecting the LID. Normally when we install LID, we like to do staging. So we would put the LID either in last, or we put them in areas that could be easily protected. That's not the case here. So what we've done is we've ensured that all of the pipes that are draining to that rock trench, because we have field drains and surface drainage coming in, the pipes currently terminate about knee-high out of the ground, and they're going to stay like that until the end of construction. That way we can ensure no water is entering those pipes, no sediments getting into those pipes, to make sure that the rock trench doesn't bind off. And then once we come in with our final grading, cut the pipes off, put the drains in, and everything will work. Another problem is material sourcing. Normally you go to a quarry, you get your 20 or 30 cubic meters of stone. We need 12,000 cubic meters of stone. It's a lot of stone. We've had to source it from 3 separate sources, and we've had to do the material testing and approvals on each of those sources. So it's a little more than what the city thought was going to happen in terms of testing and ingredients, but it's what happens when you have a football field full of rock. The dry pond's also too big to construct using best management. So generally, we don't recommend that you go into an infiltration trench. You want to scoop from the side. You want to avoid any machinery going in. This is huge. We can't avoid that. So we've got bulldozers running across the bottom. We made sure that they were low PSI bulldozers. So it's called marsh-rated equipment. Equipment that has very large track systems, and it basically spreads all the weight out, so that's less than 2 PSI. So what are our lessons learned? Well, there's a lot. So in design, these are multidisciplinary practices. I have to work with hydrogeologists, geotechs, landscape architects, my civil guys, stormwater management people. The collaboration in establishing the objectives with your stakeholders and with the team are very important. Everyone has to know what they're working towards in order to work together. Proper survey and mapping. The number of times that we've gone out and found electrical boxes where we were going to put green infrastructure, or figured out that the stormwater pipe doesn't extend high enough to overflow to. So having that survey and mapping is really, really important. SUI, so underground infrastructure. Where are your conflicts? Where is that gas line that you can't hit? You need to know where all of those things are before you can start designing, especially in an urban retrofit scenario. Those roads that you walk on, they have a lot of stuff under them. And that's stuff you're gonna have to avoid. The other big ones are your communications, Rogers, Bell. Where have they put those? Those are often in boulevards as opposed to under streets. So there's all these things that you need to make sure that you're not going to hit and you're not going to interfere with. Groundwater. As I said, groundwater is really important. You have to be a meter away from the groundwater, and these systems can be several meters deep. You need at least 1 year of monitoring for your groundwater. You need to get your seasonably high groundwater. You need to know what that freshet is. And then your soils data. So preliminary design, we may get a geotech to drop a well in and do a slug test. That gives us a very rough estimate of the horizontal hydraulic saturated conductivity. But when we go to detailed design, you need to get someone to dig down to the bottom elevation of your rock trench, and you need to do a real test. You need to do a permeameter test or a double ring infiltrometer test. But you need to know what it is, not just on the surface. You need to actually get down to where you're going to be infiltrating. We've had instances where the geotech said it was 25 mils. In real life, it was 10. It's a big redesign when that happens. Details. You want nice standard details to give it to everyone. You want your projects to have good details so that your contractor can actually build these the way that you want them to look. A lot of contractors think that this is earth moving. It's not. It's very different than earth moving. There's very different considerations. So you need good details and good construction notes. And then communication and project turnover. At a company like ours, people are leaving all the time. People are arriving all the time. You need to make sure that there's good communication on the project team so that the next person on the project knows what's going on. So that when the city person you're dealing with leaves, you can pick it up at the next meeting and have no problem. So during construction, one of the biggest benefits is to pre-qualify your trades and your contractors. Someone who knows what they're doing, who has done these projects before, always has a better project than someone who's just learning. You also want to do the construction phasing and implementation, as I said, with South or RBJ Schlegel. We changed the name on that, so it's messing me up. When you build these is very important. But at the same time, if a rock trench overflows to a storm sewer, you need to put that in at a certain point. How do you protect that infrastructure from the rest of construction? You need to do materials testing and inspection. We always recommend that you use a triple wash rock. You need someone to go look at it to make sure that there's no fines. Amended soils are actually surprisingly hard to get on spec. I've never seen one on spec. I'm always accepting something that's good enough. So you have to do the testing, and you have to make sure the materials you're going in there are going to meet what you want them to do. Erosion control. This is a big one. I've never seen one of these fail, except that the erosion control was not done properly. It's the most common reason that these will fail. You see sediment along the bottom of them, they silt up. These need to be inspected regularly. They need to be specified by a qualified person. And you need to make sure that they're actually there, because a number of times I've seen projects that just don't have the erosion control installed would be surprising. You also want a full-time inspector during LID. It's fairly easy to train someone to do this inspection, but you really do need someone standing there and making sure that everything goes in the way the drawings say, that the raking of the bottom happens, that the bridging layer is the right depth. All of these things will affect whether it's going to work or not. And then again, communication. It really does come down to communication on these projects. You'll have 20 or 30 people working on a big project. You need to be able to talk to them to make sure that nothing slips through the cracks. Then operation and maintenance. We do recommend that our larger clients create mapping so that they know where every single one of these facilities are. And that could be GIS mapping, that might be web-based mapping. It will prevent issues. My favorite example is they didn't know it was a pervious paving parking lot, so they sanded it at winter, which made it a not pervious parking lot. So having your maintenance staff know where everything is means that they know how to deal with the maintenance on it. Knowing where these are means when there's a big rainstorm, you can go out and see how they're performing. These are very important that all your departments know where these are, not just the stormwater department. Inspections, very important. You want to make sure they're draining down in the proper amount of time. You want to make sure there's no erosion, trash, damage, cars. I've seen cars show up in these. And then you want to have a maintenance manual. You don't want your maintenance people to be wondering what they need to do. Tell them what they need to do. And monitoring. Want to make sure these are working. You can monitor for a lot of things. You can monitor for flow, monitor for infiltration, you can monitor for how much the pollutants are getting removed. Some of those are much more in-depth than others. Some of those are more university-type projects. The pictures on this slide are actually of the same location in Vancouver. The nice green, clear one was when they first put in the C Street. And then the other one was in 2015 when I went and took pictures of it later. This is a classic example of not including money to maintain a pilot project. So they put in the pilot project, it looked great. Nobody's maintaining it. It's overgrown with blackberries, and those leaves never get removed, which does not help with the infiltration. So that's the end. If anyone has any questions, let me know.